If you want to understand any type of system in aviation to its deepest level, I believe it is necessary to understand how matter is created. Knowing the four fundamental forces of the universe mixed along with aviation allows us to grasp how everything around us is structured the physical world, and wanted to introduce matter in a whole new way. Let's start by talking about how everything is created. Matter is what everything is made out of. By understanding these forces, it helps to explain how subatomic particles make atoms, how atoms make molecules, and how molecules make substances, or as we call it, matter. To give you an example of why understanding matter in aviation is important. If an aluminum aircraft is being fastened by steel bolts and nuts, when you put together two dissimilar metals, such as steel bolts to an aluminum structures, over time the steel will lose electrons and will begin to rust. This will weaken the bolts and would be catastrophic to the structure of the airplane. That is why aluminum aircraft are held together by aluminum rivets instead of steel bolts. That's a good example, but the process is much deeper than that. However, I cannot get to that point unless we understand the basic forces that act upon us to create these atoms, which make up matter. Let's dive right in. Welcome to 360 Victory Aviation. Those four fundamental forces which compose the universe are 1. Gravity, 2. Electromagnetism, 3. Strong nuclear force, 4. Weak nuclear force. I am going to quickly define these forces, then dive in a little deeper to form a better picture of atoms and the forces that make them. The fast and simple definitions are: 1. Gravity is a mutual attraction between two objects. The bigger mass object attracts the smaller mass object. This force pulls all objects towards the Earth, such as an airplane. If the power plant were to stop, the airplane will start descending naturally towards the ground. This is due to gravity acting upon it. We know electrons are negatively charged. Protons are positively charged. Neutrons are neither positive or negative. The nucleus is made out of protons and neutrons, so electrons are attracted to the nucleus by the electromagnetic force. Also, this force helps make electricity on airplanes with the use of an alternator. It even helps navigation with a magnetic compass. Here is where the other two forces get a little harder. We don't usually talk a lot about them in aviation, since it starts digging deeper into quantum physics. But I would like you guys to at least hear about them, so you can visualize matter. 3. The strong nuclear force is the force that holds the nucleus of atoms together. This holds protons and neutrons together, along with the electromagnetic force, making the electrons orbit around the nucleus, thus forming atoms. Again, without the strong nuclear force holding the nucleus together, and electromagnetism acting in conjunction, we would have no atoms, just subatomic particles. 4. Weak nuclear force is the only force that doesn't hold things together. It means that it helps turn lighter elements into heavier elements. For example, when a dying star called supernova blows up, the energy released burns elements to a more complex form. Another basic example is nuclear fusion, which fuels the sun, releasing energy. I want to take a second to mention, if you are not very familiar with the term, it would be extremely helpful to look up some videos about those meanings and definitions, as this will make this video make that much more sense. My mission is to share different subjects and relate them to physics and aviation. However, this video alone will not be able to cover these complex forces in minutes. It is merely an introduction. Understanding how different matter interacts with other types of matter is crucial to determining which material to use when making repairs or modifications on different airplane structures. For example, if you are working with different types of hydraulic systems, knowing what types of hydraulic fluids will affect different types of O-rings is important. This will all depend on their chemical composition. Let us get back to the video. I want to talk about gravity, but before I do, let's look at how gravity acts on matter. We must understand some basic definitions that make up matter, such as how gravity plays no role in determining the internal properties that make up matter. Let's break down matter. First, how do we classify matter? Well, everything that you can see or feel has matter. So essentially, the entire universe is made out of matter. To be matter, it must take up space, or in other words, must have volume. And of course, must have atoms or mass. Since gravity acts on mass, we must understand how mass is measured. So let's define mass. Mass is the simple measurement of how much matter is in a body. Specifically, how many atoms are in that object. Mass is constant, but the weight varies depending on where you measure it from. An example of how weight changes is by taking a look at when astronauts leave Earth and go to the moon. They appear to be weightless, but they are in fact under a free fall with some gravity still acting on them. Since mass is constant on the astronauts, gravity decreases further away from Earth's mass. This makes them appear weightless but are not. For example, someone weighing 200 pounds on Earth. On the Moon they will weigh about 33 pounds, since there is less gravity on the Moon. Keep in mind the Moon is far less massive than Earth, thus making gravity less as well. This equation can be represented as followed. Weight equals mass times gravity. To simply summarize weight, it is the measure of how much gravity is pulling on that object. This weight varies on what part of the universe you measure it from. One concept of matter that we must be familiar with are the physical properties of matter. In other words, the fundamental phases, or states of matter. 3 basic states of matter which we all have heard before. 1. Solids. 2. Liquids. 3. Gases. 4. Plasma is also a state of matter but often not mentioned. Physical states of matter behave in certain ways. Here are some of its characteristics: length, color, density, mass, elasticity, pressure, volume, and luster. For example, if you have a container that can hold a liquid, such as a plastic gas tank, filled with liquid gasoline, you might not think the container is porous. But in fact, if you zoom into the gas tank with an electron microscope, what you would see is that the gas tank actually has tiny openings. But gasoline molecules are still relatively bigger than the container's porous material, thus containing the liquid gasoline. This leads me to define what porous is. Porosity is having pores or spaces in which smaller particles can fit when a mixture takes place. Sometimes it is referred to as granular, having or appearing to consist of small grains or granules, such as if you zoom into a bare metallic structure with an electron microscope and see the metal's texture actually has grains. When something is porous, it can hold fluids within itself. Here are some examples of porous materials: wood, rubber, sponges, and some rocks such as volcanic rock. So if things can be porous, they also can be impenetrable. Impenetrability means that no two objects may occupy the same place at the same time. Here are some examples of materials that are not porous: nettles, plastics, varnished wood, glass, and some rocks like marble. All these materials contain very few pockets of air, also known as pores. Thus, two portions of matter cannot occupy the same space at the same time. Now here is where things get a little heavy. Density. Density is the weight per unit volume of a substance. Let me ask you this. Which is heaviest? A ton of steel or a ton of feathers? Density is used to describe how much space an object or substance takes up. In other words, its volume or shape, to the amount of matter in that object or substance, also known as its mass. To help visualize density, it helps to compare how much more volume a ton of feathers would take up, as opposed to a ton of iron that is much denser and its volume would be much smaller. Another way to put it is that density is the amount of mass per unit of volume. How do we measure volume? The unit volume selected for use in the English system of measurement is 1 cubic foot. In the metric system, it is 1 cubic centimeter. If an object is heavy and compact, it has a high density. If an object is light and takes up a lot of space, it has a low density. To find the density of a substance, its weight and volume must be known. There are ways to find out the density of an object. This is accomplished by finding out its specific gravity. We do this by comparing the density of one substance to another. Water is the standard that physicists have chosen to use when they compare the densities of all liquids and solids. For gases, air is often used, but hydrogen can be used sometimes as well. In physics, the word specific means there is a ratio, so it implies that water or air was used to figure out the specific gravity, by comparing what you are weighing, also called specific weight. At last, those are some of the main characteristics of matter which I wanted to cover for this video. And as a thank you for all who watched until the end, here's a little bonus. There is a great movie called Einstein's Big Idea which is based on David Bodanis's book. This helps understand the law of conservation, which states that matter cannot be created or destroyed. It can only be changed from one form to the other. For example, when liquid gasoline vaporizes and mixes with oxygen, then burns, it seems as if the gasoline no longer exists, although it is no longer in its liquid or vapor state. The matter that the gasoline was made out of still exists in the form of gases from the burning fuel.